All right. So we're on test point 3 right now.
Yeah, no worries.
Okay.
Can you still hear me, or did the audio drop out?
You cut out for a few seconds.
Okay, so this looks good. So you can see that there's this pulse that is coming up with kind of like a step function, and then looks horizontal. That pulse, that's the peak detector. It increases to the peak of the amplified pulse, and then takes kind of like milliseconds to decay away. And that's actually what we measure. And so the amplitude, this flat-ish pulse, the amplitude of that can be related back to the original SIP pulse through like the calibration function that's described in the manual. I do that calculation in the Arduino anyways. So okay, so it looks like your circuit's good.
Yeah.
So everything's good up until the Arduino now.
We had quite concerned about that actually, because we're not using an Arduino. It's like an off-brand Nano, if you know what I mean. Could that be a problem?
No, that's fine as long as you were able to upload the code. Were you able to upload code?
Yes, we have the OLED code that I know right now on at the moment.
Oh, and it doesn't flash, eh?
No, the count rate's quite low, and I was reading your manual, but like I couldn't really figure out. But the problem is that like every time like we pick it up, usually it starts to flicker a lot, like because we're discharging, correct?
So what that is, I'm guessing you're not screwing in the SIPM PCB. So there's the two standoffs from the SIPM PCB into the main board.
Oh, so it's not screwed in enough? Is that the problem?
Are you screwing it into the bottom?
Yes, it's right here. These two.
Oh, so okay, so normally what that is when you jiggle the SIPM PCB, it loses a connection or something like that, and you end up with noise. That's what's causing that. Or it could be the other thing is if the SIPM, I don't think this is the case because your SIPM signal looks good and I don't see a lot of noise or anything. If the SIPM wasn't soldered onto the board correctly and one of the solder joints came loose, when you jiggle it, that joint comes loose and reconnects, and that can cause noise and stuff. Normally, just simply like screwing in the PCB at the bottom is sufficient. I would say your tape job could be improved a little bit.
Right.
You could try and retape it. It could also be that when you jiggle it, you're letting in some light. Normally when I tape it, I try and like cut the corners and make it as like tight as possible and put a couple perpendicular layers of tape onto it. I doubt that's the issue, but that could explain it. And if you're not screwing into the main board through those two 0-80 screws at the bottom, if you're not screwing in those tight enough, if there is still some like play, that could also cause the poor connection. So you might want to just tighten those a bit. You don't have to tighten them ridiculous, just tighten them a bit. Yeah. Okay. So since you're not, your solder job looked good. Can you explain to me your solder job? Did you get somebody to do it, or did you do it?
It was our team lead. Luke is unfortunately not able to be here today. He did most of the soldering of it, and yesterday we looked through our microscope here. I'm not sure you can see it. 1 second. We used this microscope, and we noticed that one point on the Arduino had a little hole, so we fixed that. It was on the D6. Like it wasn't completely soldered correctly, I guess. Yeah, it was missing part. So we fixed that, and unfortunately that still has a problem. So I'll tighten these screws, I suppose.
Well, that's not the problem, but making sure that those are tight, that might be the issue that's causing the noise when you jiggle the detector. But the fact that your circuit is working correctly tells me that like right now the problem is likely at the Arduino, or right before the Arduino. There's 2 0-ohm resistors. I doubt that's the problem. Your solder job looked good, but the signal, that peak detector signal, goes into the Arduino on pin A0, and so if A0, does that solder joint look okay? I wouldn't touch it with. I wouldn't touch it with metal.
Sorry. Yeah, it looks good. I can pull it under the microscope so you can see it too. Is that fine?
Typically, what I do is, I don't have a microscope here. Typically, what I do is I just hit the joints with new solder and a soldering iron to remelt the solder and let it flow again. And normally that causes any sort of poor connection to go away. So right now, what it could be is A0 could have a poor solder connection. That would explain the problem. Or if that's not the case, maybe A0 has an actual problem. Like maybe that analog pin has a problem. And maybe I saw this for the first time like a couple days ago with somebody else. You might have to, rather than go to A0, bridge to A1, analog input 1,
Okay.
and measure off at A1, the analog input 1 instead of A0. It'd be strange if that was the case, because I built hundreds and hundreds of these detectors and I've never seen that problem, but I did see it for the first time less than a week ago.
Right, and then we had to alter any in the code then. Change to the
Yeah, so
assignments.
what you would do, I think A0 is right beside A1.
Yeah.
You would just bridge the two. So you just put some solder between A0 and A1. So the signal goes into A0 and A1. And then in the code, wherever you see the word A0, change that to A1, and that's all that there is to it.
Okay. Yeah. You can do that.
So first the first thing I try is to just hit it with some new solder, pin A0. If that doesn't fix your problem, then I bridge over to A1, change the code so that all A0s go to A1. I think there's only two places you have to change it. It watches A0. It just watches that waveform until it goes above a value and says trigger detector. And then the next measurement, it says, this is my amplitude measurement. And you just have to change those two.
Okay.
Okay.
All right. So I'm not sure if you want to keep your take up more of your time while we test that out. But if that wasn't the issue, what else what's the following, do you think?
Okay, so number one, re-hit the solder joints.
Yeah.
Can you zoom into your, do you mind putting your detector closer to the camera? I just want to see what the SD card board looks like.
Yeah.
Can you rotate around so I can see it like sideways?
Yeah.
Move it down just a little bit. You can back out the camera. Oh, sorry. I'm just trying to look to see it. You don't, the pins, okay, I see what you did. You moved the Arduino up. The Arduino pins are not touching the SD board, right?
No, they're not.
Okay. Sorry, I just saw that there was like these pins sticking out.
Yeah.
Okay, that's good. I mean, since your Arduino works, you're running an OLED screen, it flashes occasionally. That's gonna solve your problem probably, for sure. If not,
right.
Look at your board again.
Yeah.
And put your finger on the board for a second.
Sure. I'm not sure. It's like
to the right, over by the. Maybe I can. How do I draw on the screen? Let me see here.
Daniel, allow you to do that? One sec.
It's okay. So I can't remember what the resistors are called, but you see where the OLED connects to the board?
Yeah.
Yeah. There's 3 resistors there right beside it to the left. Yeah, those 3 resistors. That's the only other place that there could be a problem. But like I looked at those in the pictures you sent and they look fine. The solder job looks good. But those 2 0-ohm resistors, if those aren't connected, that would also explain this problem. So why don't you hit those also with some new solder as well? Okay.
You can do it.
So how about you try those 3 things? You try hitting those 0-ohm resistors with new solder. You try adding new solder to A0. And if that doesn't work, bridge A0 and A1 and modify the code. And if all that doesn't work, I'll still be at the lab for another 45 minutes.
Okay.
You want to send me another message and I'll give you a call back and we'll try something else?
Yeah, we can do that. Yeah, definitely.
Okay.
All right. Thank you so much, Spencer.
Yeah, no worries. Let me know how it goes, okay? Even if you get it working, let me know, okay? I'd be curious to see what the problem was.
All right. Thank you so much.
No worries. Good luck.
Thank you.
Bye.
Bye. So that went pretty well, I would say.
Yeah, so wait, is he saying it's the soldering connections that from the on the Arduino that's the issue?
Yeah, the analog pins. Wait, do we want to keep recording while I'm doing this, or do we want to stop recording?
We can keep recording. Just keep recording.
Yeah, that was pretty cool meeting him. I was like unexpected. Goodness, yeah. Okay, I'm probably gonna unplug everything for safety's sakes. I can't believe I was touching the pins with my screwdriver. You can tell I'm not an EE.
Wait, what did you do with the screwdriver?
I was touching the pins with the screwdriver.
That was shorted, right?
Yeah, I had a great potential of shorting it. Oh, that was pretty stupid.
You're okay.
That's kind of nerve-wracking, not gonna lie with you guys. So the A0 pins. So how you guys doing today, actually? 1, 2, 3, 4.
Pretty good. How are you?
Yeah, not too shabby, not too shabby.
How are your projects going? Jeez, you have so many.
NSL, I haven't really done much, and I've been only doing stuff on the weekends because I have class and everything. So I'm not contributing as much as I would like. And the team where I'm on right now is kind of slow at the moment because we're waiting for the other teams to do stuff first. So I'm fortunately okay doing what I'm doing right now.
Wait,
I
did he
almost
say
got-
to
Yeah.
solder the 2 0-ohm resistors?
Yeah, these two in the bottom right here. He said that could be an issue.
Mhm.
But the last resort
You
is
wanted
to
to
bridge it.
resolder it, right? Like resolder it.
Yeah, just to make sure there's good connections between them.
Gotcha.
Send him a message. Okay. That means we have to email him. Okay. A0 is 4. 1, 2, 3, 4. Okay. It looks like there's a potential that there is actually a gap that we can see on A0. I had the wrong tip. That's fine. Are you still driving, Daniel? Okay,
Yeah, I
I'm
think
gonna
he
mute
might be still driving.
I'm gonna mute myself because the famous tractor is pretty loud, and I don't want you guys to hear that or hurt your ears. So I'm gonna mute.
That's good.
Michael, so what is the A0 pin do?
He's soldering right now. With the fans on, so I don't think we could hear
Oh,
him.
my God. Oh, he doesn't hear me? Dang. because I don't know if you heard, Isabel, but Spencer was also saying if that doesn't work, we would have to create a bridge between A0 and A1, which is the first I've heard that, but we would basically send the signal through A1 as well.
And I think he said to change the code too from all the A0s to A1s.
Right. So that's why I was wondering what A0 and A1 does.
Oh, sorry. So to answer your question, the A0 and basically is connected to the SIPO, I believe, and that's what's communicating with it. Sorry I was so quiet because I accidentally bridged A0 with another pin that I wasn't supposed to. So I had to get rid of that bridge. So I just finished resoldering it and it looks good. Yeah, it looks good. So I'm gonna connect it back. Do you guys remember what he said to do after you connect it again?
I think he just said just to test it again, no?
Yeah,
If
okay. Plug it back in powered, I guess.
Yeah. So, what did you say was the purpose of these analog pins? Like, what do they do?
If you look on the SD card that I know, or the
They
OLED,
connect
they
to
just communicate with,
the
yeah,
SD
they
card?
communicate with the SIPM PCB.
Oh, gotcha. Okay.
So up.
Right. Okay. And then it's strange how I've never heard this, the bridging between A0 and A1. They're both analog pins, but that was
Yeah.
unique.
So it's on right now. The rate is quite low. unfortunately.
The rate you
Um,
said for what?
Yeah, it's not flickering again. Like that didn't fix the issue.
Because
Unfortunately.
how did when we were talking to Spencer earlier, we were just testing the Simpom, right?
Yeah. When he said he didn't have a microscope, I was like, did I go too extra? Or does he refill his PCBs? I feel like he refills them. Which I don't have, so. I don't have the equipment to do that. Oops. So it looks like I didn't kill the board. That's good. It's a good sign. And I do wish Bronco Space had a live. We don't.
Honestly, all the labs on the school that we have is not a lot. Like even Formula doesn't have a big lab.
LRL has a nice lab. Or is
I
getting
haven't
a
seen.
nice lab.
I haven't seen. Oh wait, yeah, the LRL is right next to the.
They're building a
I
lab at
guess.
the moment.
Yeah.
Just gonna look at the. I'm not even sure. You guys, it's too lazy. I wish I was.
No, you're
I wish
good.
I had a better camera setup.
Just let us know what you see. That's it.
I'm just checking all the connections on the Arduino right now. They look good.
Did you touch up the 2 0-ohm resistors? Like, I think that's what he said too.
No, I didn't. Should I do that first? I just want to see if
Yeah.
I actually touched up the. Yeah, they look good. 1, 2, 3, 4. This one looks good. It's kind of hard to see because of the SD card PCB.
Okay, earlier when we were testing the Cosmic Watch, we were connecting the oscilloscope to the Simpom, right?
Yeah. Yeah, this looks good. Okay. let's have the
And so what is the issue right now?
Spencer just wants us to make sure that the connections to the Arduino to the board is good. And wait, so this is the resistors. Let me show you guys as well. That looks good, right? On the resistors.
Yeah, those are good.
Yeah, and let me show you. So pin 4 right there, the number 4 to the left. That's the one that he wants us to resolder, and it's kind of blurry. Sorry, I didn't change the focal length. I mean the zoom.
It's okay. The one to the left.
This one.
Can you point to? Is
I
there any way you
can't.
can
My
point
hands
to
are
it?
full. It's this one,
That
the one
one?
I'm cutting
Okay.
out right now. Yeah, so 1, 2.
You're
So
good.
1, 2, and 3, and 4. That one. So I touched that up.
Oh, okay, gotcha.
Maybe we do need to bridge it.
And he wanted to connect if it doesn't work, he wants us to bridge it, right?
He also said to retape the scintillator to make sure there's no
Like-
gaps.
So like make a a tape round right here, like that. Because there are like gaps right here, right? So he wants us to cover these ones, I guess.
I think so.
I forgot specifically. I
He
think he
just
said,
wants to make a tight lock because those little flaps, he said that could be an effect. But I'm kind of confused. So the main issue is the what is it? The Arduino, right? Is so when we plugged in the
Similar.
Simpom into the oscilloscope, we see that it's detecting muons, correct?
Mhm.
And so when we are
Wait, quick question. Simple, can we just yank it out? No, right? No, we're not yanking it out.
I think it's screwed on from the bottom.
Yeah. I should probably take it out instead of doing like this, but it's too late now.
Daniel, are you driving? You're kind of like cutting off when you talk.
I'm currently driving in a car.
Isn't that illegal, Daniel?
I'm in an Uber right now.
Oh, or tell your Uber driver hello to me for me. Okay, so this is the retaped. I just taped the sides up. Is that good? Or I don't know.
It looks good
Okay,
from this point of view.
dang. I'm so good at taping. I'm gonna put that on my resume. Really good at taping stuff. And this is back on. OLED. Plug action. And put the OLED on. Okay. Bring this for you guys. So it's, I think it's flickering red right now, red and green. So it's communicating and it should flicker soon. Should, wasn't it? That's weird. Wait, let me re-upload the code maybe.
Wait, you didn't bridge A0 and A1 together yet, right?
No, not yet. But it's not flashing anymore. So I'm connecting to my laptop. And it's not flickering red and green anymore. So that tells me the code is not there anymore. I think okay. Re-uploading the code. It's weird why it's not blinking anymore though. What did I do? It was blinking earlier. This is peculiar. It's weird. It's still working, but I don't see that one fire anymore. Like that one signal fire. I guess like is it
So what
supposed-
signal fire? What is?
like you know how it flashes once, right? Is it supposed to do that? Because when Spencer said
Right.
it only flashes once, it means that there's an error. But since it's not doing that anymore, does that mean it's working now?
I would
Not the
assume
rate.
that's a good thing.
The rate is 0 now though. So let me plug it into the. Oh,
The rate is 0 now.
it's like no rate.
Are you talking about the rate as in the Muon rate or?
Yeah. Like everything's still working. So like the rate's now 0. But when I plug it into the scope, maybe I'm blind. Oh my god. Might be blind actually, because now the rate's different.
What do you mean by the rate? I'm sorry. What's
Mu1 capture rate.
huh?
The Mu1 capture rate.
You're breaking, or I think I'm breaking up. Give me a second.
Looks fine. The rating was the same. Spencer was here. Oh wait, can you guys see it? I can't tell anymore.
Yeah, we can see it.
Cool. Does it look the same, Isabel? Can't tell.
A little bit, yeah. I can't really see it from this angle, but from here, yeah.
It's just on test point 2. And this is what's on the OLED at the moment. So I guess we do need to bridge it, right, then, Isabel?
Yeah, because he said if we redo the solder joints for A0 and A1, and if we retouch on the 2 0-ohm resistors, then we would need to bridge it. If those
Okay,
two
so it's
don't
1,
work.
2, 3, 4. Fourth one right there. Okay, so we would have to bridge it. I'm kind of scared bridging it because then you have to change the software. Guess I'll do it.
And then like you retighten the screws, right? The ones he was talking about.
Yeah.
Okay.
I see right here when I'm touching it like this. Flickers. Maybe it's loose or something. Because look, every time I get tilted up, it flickers.
What, the screws, or what do you mean by
Like when
that?
I'm pushing the board up, the LED flickers. There you go. It starts blinking. Maybe I didn't tighten it enough. Yes. Wait, so you see the block here? It's kind of like it's not. It's kind of leaning towards one way. You think that's fine?
Can you put it a little closer to the camera?
Sorry.
No, you're good. You're good. You're fine. Don't worry.
It's like a little slanted, right? Because the pin header seems a bit tall.
Is
So
it
could that
touching
be
the
an issue?
board? Didn't you say
Uh,
like it's not supposed to touch the board?
Well, I'm assuming it is because we're getting readings, right, on the scope. Yeah. So I guess should we start bridging it then? Here's 0
Yeah.
and pair 1. Okay. So that's pin 4 and 5.
Okay, I have gotten home and I'm now on my laptop.
What time is it?
Huh?
It's 12:43.
Oh God. Should she Spencer an email? Someone send him an email actually, or because he said to signal him.
Right.
Wait, I'm getting emails.
I'll send an email.
Is that him? Did he respond to us? Oh, that's someone else. Oh,
No.
he did. He did send us an email. Can someone reply to him?
Oh, it says any lookup.
Yeah, you got to all CC. He might be in your spam or junk
I got
mail.
it. I got it.
Wait, should I bridge it first or wait until he gets here to bridge it?
Wait
I'm
on
gonna
it.
wait. Yeah.
Mm,
If he doesn't join 5 minutes, I'll bridge it. I appreciate the solo commitment he has. Very appreciative. I wish we should have reached out to way sooner.
Yeah.
And whoever done it before, I should have reached out and said it to him. Charles Andrew.
we should ask him to come back, right?
Yeah, if possible, yes. Because we checked the pins, and I can show him on the scope too if he needs it. And because we're at the point that we might have to bridge it, and we're kind of scared, I guess. Don't actually say that though. I'm just gonna look for 8 zeros right now on the code.
Oh wait, you're changing them to A1, right?
Yeah, I'm just gonna make sure there's 4 that I'm finding. Yeah, okay. I don't want to do it just yet. Thank you guys for coming out here too. Appreciate it. Sorry, it was a bit last minute of a meeting, I'll be honest.
No worries. Thank you for reaching out to him and emailing him. And keep
Yeah.
catching up on all the stuff.
Okay, so just to recap, I guess, in my own terms. So we plugged at the beginning of this meeting, we plugged the, I guess, the Cosmic Watch into the oscilloscope, and we got readings. So it is reading the muons. However, when we, I guess, unplug it and turn on, or I guess turn on the Arduino, it's not allowing, or is it not? It's not receiving data from the Cosmic Watch. Is that the issue right now?
Yeah, apparently the PCB is not communicating with the Arduino, it seems.
Gotcha. And then what's next? The next thing we did was we resoldered the A0 connection, right?
Yes. I just
And
make
at
sure,
the
just tap it up a little bit.
Right. And at the same time, we also retaped the Cosmic Watch, that part. Spencer's
Yeah,
here.
the perpendicular part that he asked us to do.
Hey.
Hello, Spencer. Oh, Dan, do you want to give the recap? Or
Yeah. So we resoldered A0, or we just touched it up again, as well as we did, I guess, we retaped the Cosmic Watch portion, like it was kind of that part. Still nothing, and so I guess our next option now is to basically bridge the A0 and A1. But we're just, I guess, confirming that with you before we do that.
Yeah.
Sure, yeah, so like your detector's working, as in the whole electronics from SIP biasing, SIPM, observing a pulse, amplifying the pulse, peak detecting, that all works. So the like tape job wasn't going to solve the problem. The tape job might have solved the, like, when you're wobbling it, how it like triggers something like that. But yeah, tape job's not going to do it. Yeah, your best bet is just bridge A0 and A1. You can do this either with a little wire, or you could just put a bunch of solder in there and just glob it together to bridge the 2 pins. Do you want to do that just while I'm here?
yeah, sure. I can do it right now. Let's make sure. So 4 and 5. 1, 2, 3, 4, 5.
I would do it, yeah, on the back side of the board, yeah. If you're having trouble putting a glob of solder there, I notice you still have some like pins from the Arduino.
Yeah.
You can just cut off a little bit of a pin, maybe like 3 millimeters of a pin, and then just put it in there to help with the soldering.
Yeah, we'll give that a shot if this doesn't work.
Okay. It would be interesting if this was the problem. Maybe there was like a bunch of Arduinos out there with A0 broken right now, and that's why it's happening twice in a week. I once bought a bunch, like 20 Arduinos, and they were all broken too.
All of them?
Yeah.
Dang.
It's they were extremely cheap on like eBay or something, so I jumped on it and bought like 20.
Okay, I just bridged them. I'm just making sure 1, 2, 3, 4, 5. Yeah, right here. I'm not sure if I see it.
I don't think I'll be able to see it, but yeah,
Yeah.
it probably looks good. And then so you need to upload some new code now.
Yeah. Let me share my screen. Just make sure doing this right. I think this is the right one. Okay. So this is the one. This is the OLED. So we just need to change all the A0s to A1s, correct?
Yeah, loop through them and just show me how many there are. Just go to the next one.
Okay.
I just want to see how many there are. There should be. Just go hit find again.
Yeah. So that's 3
okay.
so far.
Hit it again.
And 4.
Oh, go back. 1. Sorry, can you loop through them again?
Yeah,
I think
sorry about that.
1. You said there's 4. I saw 3. 1. 3. Okay, yeah, I forgot about that guy.
Oh, just 3. My bad.
Okay, yeah. There's 3 of them. Yeah, you're right.
Okay.
And
so
you just sure A1. Yeah, replace all. Upload.
Okay. I'm just gonna make sure that I actually did it. 1. Okay, cool. It did, and I'll upload the code.
So just to confirm, I guess the analog pins A0, it's just to basically communicate between the Arduino and the PCB, which I believe, right? Is that the main reason why we use A1 or A0?
There might actually be 2 analog to digital converters on the Arduino, and maybe one of the ADCs is actually broken or something. Okay. So I don't know. I'm not really sure. We'll try this though.
Okay, I'm uploading it.
When I saw this problem last week, or the problem with A0, I didn't dig into the Arduino to figure out what was going on. I just noticed that when I used A1 instead of A0, it just suddenly worked.
Okay.
It might have actually been with somebody else was also launching a balloon right away. Actually, maybe it was a rocket. No, they're doing rockets. Never mind. Okay. Is your detector blinking now?
Total count is still it's 0 at the moment, and the rate is 0 as well.
Let me look at the schematic. Maybe
you might have done something wrong, I suppose. Oh, I lifted it up and it's blinked.
That could be just bumping the connection or something. It's hard to say.
Yeah.
Can you check test point 3 again? If test point 3 works, like it's a problem with the Arduino. Perhaps the Arduino's, hopefully not, but it's possible that the Arduino is broken. I've seen like maybe 5 broken Arduinos, not excluding the 20 that were completely broken. 5 that it broke during manufacturing out of like maybe 300 or 400. But when they break, they typically don't allow you to like upload code or run the OLED screen or anything like that.
The BNC looks fine. It looks better actually for some reason than the last time we did it.
It shouldn't look better.
Yeah, maybe I'm remembering correctly. I did change some settings when you left. So test point 3, correct? And test point 4.
Yeah, there you go. Yeah, that looks good. And you're sure that the bridging that you did on A1, you think that's a good connection?
Yeah, I'll just put it under my the microscope and just bring over my camera.
I mean, you don't need. I wouldn't say you need a microscope to see whether or not the connection's good. You should be able to just visually look at it and be like, yeah, that looks like it's, it looks like the solder is like grabbing onto the metal. It's not like 2 separate balls, like
no. I just wanted to, in case you wanted to make sure.
Okay.
But yeah, they're definitely bridge.
Why don't you try bridging A2 as well?
So A0 to A2.
Yeah, we'll try A2 for one more thing. It's super strange that you're able to like upload code, talk to the Arduino, run the OLED screen.
Yeah.
Really, the only other, if this is the case, either your ADC on your Arduino is broken, which I doubt it. That sounds strange to me. Oh, one way you could test it is, okay, we'll test something else real quick after you're done bridging. Oh, remember to disconnect the detector while you're soldering.
Right. Exactly.
To communicate with the Raspberry Pi, you didn't do anything to this code, have you? OLED1?
No, we haven't. No. I just clean slated the code and copy on the IDE.
Okay.
This is all clean norms. Yeah. Okay. I bridge all three at the moment, and should I change it to A2 now?
Yeah, let's try that.
Okay. I2s. Up code. Should I wipe out the Arduino first and then upload the code, or should we find this uploading straight out?
What do you mean? Wipeout? Wait, sorry.
Just open up a blank sketch and upload that so it can clean, I guess.
Sorry, my volume is kind of low. Can you repeat that one more time?
Oh, just upload get a new sketch right here and upload that first. So then it's clean, and then we can upload this one that we edited. Should that make a difference?
No, not at all. You can just upload OLED_1.
Okay, uploading.
Well, it's okay. Let's just see if this doesn't. And like what you should see is it'll come in with like it's completely a random process. So you should see like random pulses basically firing order hertz, maybe 2 hertz, depending on how well you taped your scintillator.
Right.
Nothing, eh?
Yeah, the rate is absolutely 0 at the moment.
Okay, let's try go to file in the OLED code.
Yeah. Sorry, you need.
Or file, sorry. No, not search file, top left button.
Oh, yes.
Examples. Analog. Analog input. Yeah.
Okay.
And then try and upload this one. And you see how it says A0? So
yes.
It's right now it's trying to measure whatever's on A0. And what I'd like you to do is just now far right, you see the serial monitor button on the very far right top of the screen.
Yes.
Hit that button. And you might have to
redo it, I guess.
No, it should be good. How does this thing work? What does it do? Digital write. Can you scroll down in the code? I just need to see what the analog thing is. What is it? Does it measure something?
An LED pin to 13.
What is sensor pin? Sensor pin. Oh, analog. So it does read it and then makes a delay. Yeah. So you see in the code the analog code. Sorry, go back to the analog code. Where it says delay, type delay 10. So add 1 or 1. Yeah, I think this is. Yeah, just put the number 1 in there. Sure. And get rid of that next delay too. I just want to see what the or like type sensor value. Just set that to 1. Or yeah, sure.
Okay.
I just wanted to spit out what it sees on the ADC. Is basically what I wanted to do.
Okay.
I'm not sure. Is your Arduino connected to COM6?
Yes, it is. I just make sure it is.
Is your Arduino plugged? It must be. Okay.
Yeah.
Can you, in the loop, can you type capital serial dot print, or do you know how to serial print in this?
Yes.
Right. I think it has to be capital S. Or,
Okay, we can take a capital S. Okay. And re-upload it. That's correct.
I think his Wi-Fi cut out.
Yeah, I think so as well. It's weird how the serial.print isn't printing either.
So what is this code supposed to do? So it's supposed to...
It's supposed to give you values based on the sensor, which theoretically we don't have a sensor.
Select an input. Variable to store the value coming from the sensor.
Ugh, I don't know what's wrong. It's just peculiar. Let me make sure I'm using the right function, I suppose. Zero.print.
I think
Yeah,
print
it should be.
might be capital. The P might have to be capital, or print ln or
Yeah, I looked it up just in case. I think
Okay.
we had the right function, I guess.
So it's not doing anything.
Yeah, unfortunately.
Sensor pin A0. Can you try that's weird.
Spencer, actually before this, like a few weeks ago, we want to make sure the SD card worked. So we did save some files on SD card and prompts are showing up on the terminal. So that it does work, but for some reason it's not working right now.
What's the communication? Oh, it doesn't say the communication speed here.
Yeah.
Maybe no, it should still spit out like weird numbers then. Try like open sketchbook, open a different sketchbook, open
Yeah. We can use it with the example that we used that we got readings from where it was some SD and card info, I believe. That's one we used last time and it worked. Do you want to try that one?
I don't understand why this isn't working though.
Yeah. Apologies about that.
Read LED.
Wait, the red light on the Arduino is on right now. I don't think that just means it's communicating, correct? Like it's constantly on.
Which LED is?
The red one. Oops.
Oh,
Yeah.
The red one. So the red one is there's a power LED, and then
Yeah.
there's an LED on pin 13. And this code here, it tells you pin 13, write that high, then delay, then write it low. So it should be blinking is what, when you uploaded this code, that light should blink.
Yeah,
I think
unfortunately, it's like staying constant rather than blinking. So the red is staying on. Yeah.
That's strange. It's try the blink code. So file example basic or digital, one of the top two. Basic, yeah. And then upload this one and it should flash that light. I think it's a green light though.
Okay. 1000. Should we change that?
No, it's okay. That's 1 second. So it'll turn on and off every second.
Yeah, it's blinking.
Oh, I see what could be going. So probably what happened on go back to the analog one. Yeah, so rather than delay one, go delay 100, and then we'll just verify that, or 1000 maybe, and we'll just make sure that it does blink. should go on and off. Yeah, let's try that again. Ah,
Yeah, it is.
okay. And so the problem, it's still uploading. Okay, so that's cool. So actually the problem here is I think we have to make a serial communication line. That's the issue. So do you have my code, the OLED code?
Yeah.
Can you open that up as well? Or just go back to it?
Yes.
At the
Sorry.
top of the setup, there's like, or search the term 9600.
Baud rate.
Yeah, and you need that line there. You have to begin the serial communication before you can talk to it. So
Right.
maybe copy that over, copy that line
Right.
over to the analog script. Sorry, convoluted way to test the ADC.
Where is it at? This one. Yeah.
Yeah, and then in the setup at the top, underneath it, yeah, right there, paste it in there. Okay, and then upload, and hopefully this works. Hopefully now it'll read out hello every second. There we go. Okay.
Oh yeah. Okay.
Sorry. Now what I want you to do is print the sensor value instead.
Okay.
Yeah, so just copy sensor value, print that rather than hello.
Sure.
And then I want you to, rather than the delay every second, delay 10 milliseconds, so just 10 instead. So it just continuously spits it out as quick as possible.
Gotcha.
There.
And turn it up again. Okay.
Oh, you got a print line, print ln.
Oh,
sorry.
Oh, forgot. Okay. Ellen. Is this that?
There we go. And try and upload again.
Oops. And if I bring up terminal. Okay.
What number it is? Okay, so I see
It's
like 10. Now take your
Yeah.
finger and touch A0. So now you're creating like a weird RF signal. You know, you're touching it. You're this conductor. Do you see the numbers changing?
I'm currently touching it, but like it's not. Is it changing? I can't tell. Yeah, it's like going to 20. I saw a 20.
You could literally take a wire, touch A0, and then touch it to like 3.3 volts, like the 3-volt line or something, or just run it around the board. If you can hold it,
Okay.
run it around the board and see if that number changes. Like it looks like it's working correctly.
Yeah. I don't have a wire on me. I have a screw. Would a screw work?
Sure, touch it with the screw. I mean, like these numbers should jump around quite a bit. You should see, like when you touch it, you should see the numbers change. Like some correlation when you touching it.
Swing it around the analog pins.
Oh, there! It looks like it's doing some
yeah.
weird stuff, right?
Yeah, it went to like 100. Like I'm just touching it very briefly. Yeah, it's changing. Yeah.
Oh, there you go. I saw like 100. Yeah, okay. Okay, so like the analog part works. Try the bottom of the board on A0. Like on the bottom of your, or were you just touching the bottom of the PC?
Yeah, I was. Should I do the top part instead?
No, like it looks like the ADC is taking data. Let me look at the schematic for a second.
Wait, could it be possible that we shorted something that we don't realize we shorted? Could that be a possibility?
Those 3 resistors by the OLED.
Right.
You know what I'm talking
And
about?
if we were to just probe it with the oscilloscope and we get readings from it, does that mean that's not shorted then?
Depends what you mean by a short. What do you mean by a short?
Like how
like
do you
where?
test something that's shorted, I guess? Like,
So it depends on what's shorted. If a power line shorted, you'll see stuff get really hot,
right.
Burn up. That's not the case. If the signal line is shorted, you wouldn't see the peak detector pulse if the peak detector had a short in it.
Yeah.
So the peak detector generates a charge that slowly bleeds off through a resistor. If you had a short there, it would bleed off too quickly to see anything. It would just be a ground. So you don't have a short on the peak detector.
Right.
Let me just check one more thing. So I need to look at the schematic for this particular version.
Out of curiosity, Spencer, when are you gonna publicly release V3? Because I looked at the GitHub. It said it's for the lab currently at the moment.
Yeah, I probably won't release V3.
Right.
It's this project requires a lot of like maintenance. Like I'm the only one that works
Right.
on this, and I just have to spend several hours a day sort of helping people get the detectors working. Another version would just cause it to be sort of unwieldy, and I wouldn't be able to keep up with the project.
Roger.
And not only that, but V3 is much more harder. It's much more complicated to build, so there'd be even more like problems in troubleshooting. So instead, I'm building like a different version. That's right now to measure muons, you actually need two detect. Well, you measure muons with one detector to actually make like 100% pure muon data sets. You don't really care because you're going like at altitude where there's only muons anyways. But like if you wanted on ground to measure muon angular dependence or going a subway or something like that, you typically use two. And I'm going to put two detectors together and then update everything with a new microcontroller and temperature sensors and real-time clocks and all that stuff, GPS, that kind of stuff.
Oh, that's cool.
V3 has all that already built in, but yeah, I'm worried about releasing V3 to have people build it. Maybe I'll release it as, I don't know. I don't know. I get a lot of emails about V3 as well. Okay, so anyways, can you look at your PCB again? Do you have your soldering iron going again?
Yeah, it's I believe it's still on. Yeah.
Oh, sorry. Upload the OLED code again. Set it back to A0 just for kicks.
Okay.
It shouldn't matter. Yeah,
we
might
have
set back to A0 just because we know A0 works.
Okay, this is A0 and I'll upload it. This is the one I didn't alter, so I had two OLEDs up.
So,
Okay. And it's starting back up.
So, can you show me your test probe? What were you using to test the circuit? It's like a hook, right?
Yeah.
Touch A0 right now and see what on your can you look at your oscilloscope and touch A0?
Sure. Just like touch it with the probe.
Yeah.
Okay.
I mean, it's pretty much connected to test point 3. So it should look the same as what you were seeing on test point 3, but you still want to trigger on the BNC. So trigger on the BNC and then
Okay.
Test point on the A0. So I'm thinking that the issue is actually, I said there's those 3 resistors near the OLED. I'm wondering if one of the pads on one of those actually came off and is broken.
Oh.
It's like the signal is getting old.
Oh, I believe he cut out again.
What is he talking about the pad on the resistor?
So you see these pads right here, like these copper pads right here, Daniel. They have that on that you solder on to the like those copper silver things.
Oh,
Let's talk about those. That's where you solder on, and that's how a PCB like keeps the solder at one spot, and that's why there's this green
gotcha.
stuff is solder mask, so it's masked to soldering, so solder doesn't get on it because that's mask, right? So yeah. So he said to touch A0. I'm gonna touch A0 right now. Wait, is Spencer back yet? Oh yes. Okay.
Yes. Yeah, I am. Okay. So I think you saw bridge A0, A1, A2, whatever. You can just touch that whole glob of solder.
Okay, I'll turn it around to do that.
And we'll just try and hopefully see a pulse. And
should I leave it on that area? Yeah.
So you still need to trigger. Make sure that you can still trigger on the BNC. I haven't seen your screen update. Oh. Can you just like maybe lower the threshold first? You want to make sure that you can see a pulse first.
Yeah. There you go.
Okay. Now let's go back to A0 and wait for a pulse to come in.
It's flashing, or flash once.
Sorry, I can't see the.
Oh, sorry.
Oh, there you go. Yeah.
It might have been because I was touching it actually. Oh, there you go. Yeah.
It worked.
It didn't flash, but I'm seeing spikes on the scope. On the second channel, which is purple. So it seems like it's working. See if it happens again, I suppose. Yeah, there you go.
Yeah, that's so weird. What?
So the ADC does work.
The ADC works and the pulses are coming in.
Yeah.
Can you
Well-
can you show me your OLED code again?
Yeah, absolutely. This one I have on right now is the raw one, so it's this one. Yeah. Or the alter one. Did you want to see that one? Or
On your board, what is R17 on your
R17?
is there an R17 on your board? It should be like kind of in the middle by the temperature sensor. Is there an R17?
there, yeah, right here. Yeah, there is. It's right there.
Shorted?
Not sure. I can test it with a scope if you want.
Oh no, there's you don't need it. I mean, like, is there something on R17?
Yes, there is.
Okay. All right. Next up, let's scroll up to the top of the code. Look for the word reset, signal reset. You see signal reset or reset threshold?
Yes.
Change that to 25, because maybe what's going on.
Okay.
Maybe what's going on is like somehow your Arduino is outputting some DC voltage-ish on the ADC, and it triggers on one event and then just never resets the detector. So normally it waits for the pulse to get below a certain ADC value before it says, all right, look for a new pulse. And maybe for some reason you have some DC offset on your ADC. So let's try and upload this code and then see if that is the issue. But I mean, I saw like ADC values that were like 10 and sub 10.
Yeah. Oh wait, Spencer, I think that fixed it. The threshold value. Like it's flickering on now.
So I guess what's going on is your Arduino has some DC offset. It's not.
Yeah. If you like, I can show you the.
What's that?
Oh, I can show you the link of the Arduino we got maybe, because it is an off-brand as like we mentioned before, so that might contribute to it.
That's super weird. I don't even know if I've seen this before. I feel like I've had to change the reset threshold once, but I don't know if it was the same reason. That's
What's
super
peculiar? What's peculiar is that we actually tried to change the reset threshold like before this meeting, and that didn't fix it. But for some reason, it fixed it now. Maybe it's because we bridged it and now it's working. I'm not sure. But yeah, we did actually try to mess around the threshold before. Oh wait, the problem is that I lowered the threshold. Oh, never mind. That's probably why it didn't work. Wow. Okay. Wait. Daniel. Oh, okay. Just making sure because I thought I logged out.
I think you logged out. So is this only for the LED?
What do you mean?
Or is this the actual code to actually see the new ones? Oh, okay.
Wow. Okay. That's interesting. That's a new one for me, I think.
Yeah.
Okay, but it's working, right? Like, what is the?
Yes, sir. The count rate's 1.073.
Yeah, that sounds about right for these detectors.
Yeah.
And like your threshold set right now, your threshold set a little bit high. Whatever, it doesn't matter. It means like maybe some like gamma rays you won't trigger the detector, but you're gonna collect all the muons anyways. So it's fine to run the detector like this. I wouldn't worry about it. You're not trying to measure background radiation. You're trying to measure ionizing radiation, which is all going to have like pretty much, I don't know. Let's see. Inside the instruction manual, I show a distribution of what the muons look like in the ADC, and so I think everything's above 50.
Let me pull that up.
Probably instructions, and then probably one of the figures. Or example measurements, probably.
22.
Oh,
oops.
No, maybe. Sorry, I actually haven't. I forgot this is what this one looks like. Maybe scroll down a bit more to all the pictures. Hopefully, I included it in here. Oh, okay. So you can see like bottom left image there.
Yes.
So the terminology here should be coincidence detector. The slave
Yeah.
detector is just muon signals. And you can see that you're probably, if you set the threshold, oh, that's not in ADC counts. Try there was a physics document on this. Is there? Yeah, yeah.
Yeah,
Can you go back?
is.
Yeah, or maybe it's the physics document I want. Sorry about that.
No worries, all.
I pretty much, like, I haven't, this project here, like, has been pretty self-sustaining, or not self-sustaining, only needing troubleshooting, and I haven't actually, yeah, example measurement of coincidence measurement, that one there. I think 6.1 is what you want.
Yeah, let me just do this. Oh, I can't. Never mind.
Hopefully I do it in 80. I don't know if I do it in ADC counts.
Okay, it's right here.
Yeah, keep going down. Right there. That guy there. Oh, it's okay. So we need to convert, most of the coincident events, muons, look like they're above sort of 30 millivolts.
Yeah.
So now we need to convert 30, if you look at 30 millivolts with your cursor. And keep going to the left a bit. Left a bit more. That's where 30 millivolts is. Most of the red distribution is to the right of that, and that's the muons. And so now we need, what is 30 millivolts in ADC counts? So if you go to the calibration curve, it just hopefully, I don't know if that's it's probably in here. Maybe type calibration, search calibration. Oh, sorry.
I would
Let's
have
see
to I can download the document if that makes it easier.
It might be in the instruction manual, to be honest, the calibration. I'm not sure if it's in.
Okay. Oops.
Maybe, keep them both open. Okay.
Oops. Yeah.
It's definitely in the instruction manual for sure. It would definitely. Yeah. Calibrating the electrons, 5.2. You're looking, there we go. So this is the calibration curve. So this is how you convert between millivolts and ADC counts. So in that inset window, in that inset window, you can see like a millivolts of 30. You can't really see, it's off the scale, right? Yeah. It goes up to 24, all the way up to the top. Yeah, that's 24. So I said everything's above 30. That means everything's above like 24. It looks like pretty much all the muons have an ADC count above 120. More or less. Right. 95% of the muons had an ADC count above 120 or so. Which means like you setting a threshold at 25.
Yeah.
You could have set it at 120 ADC counts instead and still collected. You wouldn't trigger nearly as often, but you'd still be collecting pretty much all the muons.
Gotcha.
Does that sort of make sense?
Yeah, that makes sense.
Okay. Yeah. So like you could raise that up a bit if you're concerned with resetting. You could bring it up to 40 or something if you wanted, and that would still be a really low threshold for muons for ionizing radiation. Like when I'm talking about ionizing radiation, I'm talking about like stuff coming from the sky, ionizing from cosmic ray muons or cosmic rays.
So do you want me to just upload 40 and see what happens, I guess?
Sure. Since your Arduino has something funny, some DC offset here, you could keep the threshold relatively high. Your count rate's going to be lower. Your count rate's going to probably be sub 1 now. Your count rate's probably going to be like 0.8 or something, slightly lower, but you're still triggering on old muons. So, you don't care about background. You're collecting all the muons. You might want to just leave it like this.
Okay. Yeah, it's like 0.6, 0.5.
Okay. Yeah, it'll probably average out to slightly below what you had it before, 0.6, 0.5, something like that. And you can kind of estimate the purity of that background to muons based upon that physics measurement, plot in the physics paper. At the threshold of, you set it to 40, whatever that is in millivolts. So what is 40 here? Sorry, go back to that. So what's 40 here? 40 is, you kind of have to guess. It's hard to say, I guess. But anyways, if you go back to your, I guess my point is if you go back to the physics paper plot again, sorry about that.
Yeah. So I closed it. He's like section 5.2. Yeah.
6.1. Keep going. My point, yeah, right there. My point here, the threshold you're setting is that very low step function, like at the very end, way down there in the green. That's where the threshold is default set. So you're moving the threshold to the right. So you're cutting out a lot of this high peak green distribution. That's why your rate is decreasing, right?
Right.
Because you're cutting into an exponential. So you're actually your rate should change quite a bit as you move that threshold higher. Because you're carving into an exponential decay. Does that make sense?
Yeah. Yeah.
Okay. Anyways, I would recommend trying to, jiggle the detector and see if it triggers and makes noise and stuff. Because like your balloon's going to be pretty stable, so it probably won't be a huge problem. But you want it to, survive while it's, balloon pops and falls down and stuff like that.
Right. Absolutely.
But I think it's pretty solid like this. You could probably just launch this and it'll probably more than likely just work just fine.
All right. Thank you so much, Spencer. This is like.
Thank you
great to
so
hear.
much. Oh my gosh.
Yeah.
Yeah. Sorry. You I've helped hundreds of people troubleshoot, and you ran into a new one for me, so it was good for me to look into it too.
All right.
right.
We're sorry about keeping you like 30 minutes over, but thank you so much again for coming out and speaking to us. It was a great honor meeting you.
Yeah, happy to meet you guys. Thanks for showing me this. Good luck with
Thank
the flight.
you.
Bye.
All right. Bye
Thank
bye.
you, Spencer. I think we cut him off, and then he got a little mad because we've been cutting him off a lot.
He wasn't mad. No, he's good.
Before Isabel says something, that's too close. Oh, sorry guys. Before Isabel says, he's supposed to say best of luck, however, but he's like, oh, okay, bye.
I know, I felt bad.
Oh my god.
Fine, it's
wait,
fine.
wait. Charles told us to do this actually.
What do you
Share the
do?
threshold.
Okay, what is that
He asked-
threshold? I'm like kind of confused what that threshold does.
Isabel, do you want to explain or?
No,
you
you got it.
Okay. I'll be honest. I'm a bit because so a threshold, right? It's like playing a game. You got to reach a certain threshold to get past something, right? So
Yeah.
basically, the reason we need to get needs to pass the ADC or sorry, not ADC. The millivolts, right? Because photons release millivolts, right? Photons are a type of energy, right? By light. So since if we were to set at 40, that means that the ADC value has to be a certain amount for it to actually detect it, right? So previously before we had it, so there's something wrong with our ADC on our nano. So previously he had it like around, what was it, 15? So right here, right?
Yeah.
So the ADC values that it'll read or cut off at is right here. And since we increased it, we reduced the amount of noise you're actually detecting, right? Because before that, we were also getting data from the USB, the power, the oscilloscope, even the microscope, right?
So
it's too much
decreasing the
noise.
threshold allows basically to decrease the noise, that's the surrounding noise. Is that
No,
right?
increasing it the opposite way. So since we increased it, we took out the noise that we're receiving.
Oh,
Oh my
so
god, this is so like
what?
so great. This is so great. I wish I wish I was an EE now.
So we actually increased the threshold up to 25, and now we increased it to 40, right?
Yes, sir.
And that would actually make it more. It would decrease the noise to more
Yes, sir.
something. Right. Okay. Cool. So we got it to work. We're done.
Yes, we did.
We
Great
can
job,
launch
y'all.
this weekend. We can launch this weekend.
We can launch this weekend.
Yeah.
Yes.
Yeah. Nice job, Michael. Nice job, Michael.
Oh, great job to you guys too. to be
No,
honest. You guys helped a lot during this meeting. I don't think I could have done it. I
Damn.
felt like I was in the
that's-
presence of someone greater than me, and I was like kind
like
of scared.
Spencer. Damn.
Yeah. Wait, I'm gonna stop the recording. Yes.
We should like write him a thank you email later.
Yeah, definitely.